Okay, here we go, the final Edpuzzle podcast. So, the volume of a sphere. We did surface area, now we're doing volume. It's a little bit more complicated formula in that it has a fraction in it. Oh dear. Volume is 4/3 times pi times the radius cubed. This is the first time we've cubed a number for a formula, but that's okay, we can do it. It's not a big deal. So, that's our formula for the volume of a sphere. So, pretty simply, let's find the volume of a soccer ball. Radius is 4.5 inches. How many cubic inches are in a soccer ball? So, we're going to take 4/3 times pi, a decimal problem, so context, we can use a decimal approximation, times 4.5 cubed. Now, order of operations here. We do have to do the 4.5 cubed first. So on our calculator, a lot of times we're going to have to go 4.5 and then the key that looks like this. That's the exponential key. So if we're going to do that, make sure you find that on the TIs. That's just to the left above the x squared button. So 4.5 and then to the third power. That's how I do that. That's 91.125. And then multiply that by 3.14. Then multiply that by 4 and divide by 3. And I get 381.51 inches cubed. Okay? So you can think of this instead of 4/3, you can think of it as multiply by 4, divide by 3. Okay, multiply by 4, divide by 3. That's another way of thinking about this, especially when we're working in decimal. All right, so there we go. That's super hard. Now you try it. The sphere radius is 6 inches. For this particular problem, let's keep things in terms of pi. So we aren't going to decimalize this one. So what is the volume? Okay, now let's work it backwards. The surface area of a sphere is 324 pi square centimeters. Find the volume. Oh my. This is a tricky one because we have to use both surface area and volume formulas. Surface area for a sphere is 4 pi r squared, which in this case is 324 pi. So we need to solve that, which we had practice doing yesterday. We divide by 4 pi. The pi's, of course, cancel. And 324 divided by 4, that's going to be 81. So r is the square root of 81, which is 9, and it is centimeters. Now I know the radius. I have to use the volume formula. So that's 4/3 times pi times 9 to the third power. Now 9 to the third power is a big number. I think it's 729, yep. Okay, so 729 times 4/3, or 729 times 4 divided by 3. So I take that times 4 and divided by 3, gives me exactly 972 centimeters cubed. Now that's as quick as it goes. Okay, I needed to use both formulas there. So it was kind of interesting. But again, it's not that anything here is hard. We just really need to know our formulas backwards and forwards and be able to use them literally backwards and forwards. Just like we use it backwards for surface area and forwards for volume in this exact problem. All right. How about this one? Find the volume of the composite solid. So what we have here is we have a cylinder. Okay, we have our cylinder. And we're kind of taking a hemisphere out of it, or a half of a sphere for volume. So my plan here is I have to find the volume of the cylinder minus 1/2 the volume of the sphere. Why half? Because we only have a half a sphere there. So it's a hemisphere, a half sphere, so we only need half the volume. Now we do know a couple things. We know the radius of both the volume and the sphere, or both the cylinder and the sphere, and we know the height of the cylinder. Okay? Radius of the hemisphere and the cylinder are both 2 inches. The height of the cylinder is 2 inches. So the volume of the cylinder is base area times height. So that's pi r squared times height. The radius is 2. So it's pi times 2 squared times another 2, or 8 pi inches cubed. The volume of the sphere is 4/3 pi r cubed, which is 4/3 times pi times r cubed, which is 8. 8 times 4 is 32. 32 over 3 does not reduce, so we'll leave that as 32 pi over 3 inches cubed. However, I'm only using half the sphere, so I have to divide this by 2. 32 divided by 2 is 16. Okay? So I could have done 32 pi over 3 over 6, when then reduce it to 16 pi over 3, I just take the 32 divided by 2. Either way. Once I've got that, now the total volume is going to be 8 pi minus 16 pi over 3. Now, and by the way, that's going to be inches cubed. We can combine those. 8 is 24/3. Okay? 8 is the same as 24/3. 16 pi over 3 is 16/3 pi. 24/3 minus 16/3 is 8/3 pi, or 8 pi over 3 inches cubed. And there is my exact volume of that particular shape. A lot of stuff going on here, including some work with fractions. That's a challenging little problem. All right, final slide. The radius of a sphere is 5 yards. Find the volume of the sphere. 4/3 pi r cubed. Very straightforward question. R is 5, so we'll put that in there. 5 cubed is 125, so 4/3 times 125 times pi. 4 times 125 is 500 pi over 3, and that does not reduce, so we'll just leave it that way, and it's yards cubed. We give it context. So yeah, a little bit of fraction work here. Got to be good with our fractions. The diameter of a sphere is 36 inches. Find the volume of the sphere. This is your final ed puzzle question. Final one. Give it a shot. You better get it right. And our final example of the year in a regular podcast, the surface area is 576 square centimeters. Find the volume. We did one just like this. Surface area is 4 pi r squared, which is 576. Now, I think it's supposed to be, I think that's where this pi goes. There we go. 576 pi. That pi seemed out of place. So divide by 4 pi. Pi's cancel, 4's cancel. 576 over 4 is 144. So R equals 12. So my volume equals 4/3 pi r cubed, which is 4/3 pi times 12 cubed. I do have to do the exponent first. 12 to the 3rd power, that's a big number. 1728. Four times 1728 is 6912. But fortunately, 6912 does divide by 3 evenly, so that's 2,304 pi and centimeters cubed is our context. Okay? So math work, calculator work, fraction work, and formula work. It's all here. The only thing we haven't included in this last lesson is the right triangle. I know, you're sad. Well, anyway, that concludes our Ed Puzzles for the year. That concludes the podcasts. It's been interesting, and hopefully we will have some more time to do some reviewing for the exam. Again, make certain that you know these formulas. In addition to the formulas that we've had in the other podcasts that you need to know, now we have 2 for spheres. Make sure you know them. All right, that's it. Talk to you later.